We're going to look at some problem solving with quadratic relations. Before we do, a little physics lesson. The important thing to note, you can ignore this whole portion over here if you want. The important thing to note is when you're given a situation where something is being launched into the air and you know two things: the initial speed or velocity that it is traveling. Okay, velocity means that there's an actual direction to the speed, and the initial height. You can fill in this formula with the initial velocity and initial height going in these respective positions, and you can find the quadratic model for that. Now, for those of you that are interested, this is the equation, an equation that models the height of projectiles near the Earth's surface due to the acceleration due to gravity, and that's what that negative 4.9 portion at the front there is actually working with, is the acceleration due to gravity. The actual physics type formula for the modeling any projectile height is the height times 1/2 the acceleration due to gravity times t squared plus the initial velocity times t plus the initial height. So this g being the initial the gravity. So this could actually work if you had the acceleration due to gravity on the moon, or if you were not near the surface of the Earth, but if you were further up in the as you near into space, and that the gravity is going to decrease to a degree, and so you can use this to model the acceleration or the height of a projectile at any given time. But our Earth's gravity, the Earth's acceleration due to gravity, I missed that earlier, does accelerate things down, but that's why negative, by 9.8 meters per second squared. So that is the actual acceleration due to gravity near the surface of the Earth. And thus we use this formula for many of our acceleration models. But again, the important part is you just use this formula and fill in the v0 and h0. That's what the 0 means, the initial velocity and the initial height. And then you can create a quadratic model. So given the first question here, create a quadratic model of a ball thrown upwards at a velocity of 10 meters per second from a height of 1.5 meters. So it's being thrown at 10 meters per second. So that's our initial velocity. That goes in this position. And then this value here, the 1.5, is the initial height, and that goes into this position. So a quadratic model of this would be h equals negative 4.9 t squared plus 10t plus 1.5. And that there would be a quadratic model of a ball being thrown upwards with an initial velocity of 10 meters per second and an initial height of 1.5 meters near the surface of the Earth. So our first question, how long, using that, is how long does the ball take to fall back down to the Earth? So when it hits the Earth, what's the height? The height is 0. So when is h 0 is what that question is asking. So what time will the ball end up hitting the Earth is what we need to find out, and then we can find out how long it actually takes to fall to the Earth. So here we have our equation with h set to 0. We need to find the zeros. We need to solve this for t. So we can do that using the quadratic equation. And so x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is negative 4.9. So now we can go about calculating this and working it all out. I'm going to do it in relatively short fashion. If you want to know more about solving quadratic equations, look at the video on solving quadratic equations. But under the parenthesis, or under the radical there, we have 10 squared minus 4 times negative 4.9 times 1.5, and so take the square root of that, and we have negative 10 plus or minus 11.4 over negative 9.8. So there we have the two possibilities, and then we just break those up into the two possibilities. So negative 10 plus 11.4 divided by negative 9.8 is negative 0.1, or actually this shouldn't be x, this should be t equals, just to keep things consistent, the time equals negative 0.1. So that's not going to be useful because the time starts at 0 unless we're going back in time, and I do not think we are time traveling yet. I don't think we figured that one out. Negative 10 minus 11.4 divided by negative 9.8, and we get 2.2. So this here is our value. So it's going to hit the ground at 2.2 seconds. So it's going to take 2.2 seconds to hit the ground and fall back to Earth. So the next question says, what is the maximum height of the ball? Well, two ways you can do this. You can complete the square of the initial equation that we made up here. So we can complete that square and find the vertex. But we've already found the zero, so why don't we just use our two zeros, knowing that the vertex is going to have a t-value in the middle of those zeros. So the t-value of the vertex is negative 0.1 plus 2.2 divided by 2. And if we calculate that, we're going to get, and I can probably do it in my head, but 1.05. So that is the vertex is going to approximately occur at 1.05, and then the h value of the vertex, the height of the vertex here, is going to be negative 4.9 times 1.05 squared plus 10 times 1.05 plus 1.5. So we just calculate all that out. That'll give us the height at the vertex. And when I work that all out, I'm going to get about 6.6. So the maximum height of the ball is approximately 6.6 meters in this case above the ground. So we were able to use the zeros that we had to find the middle vertex, and then use that to find the height. Again, you could also use completing the square method on the initial equation, but this is a little easier in this situation since we already have the zeros. The next part says, when is the ball over 2 meters above the ground? Well, that means that when is the height 2 meters? And so what times in this case, is the ball going to be there? Well, we just set that up with the h equal to 2. And now if we rearrange this so that we subtract 2 from both sides, we can solve this. And there we have it all set up. So we have our A, B, and C, and we can plug that into the quadratic equation and solve this one for the times that we're looking for. So negative b plus or minus the square root of b squared minus 4 times A times C all over 2A, sorry. Jumping ahead of myself here and calculating it. 2 times negative 4.9. So I'm just plugging that in to the equation. And then I'll work that out. And again, I'm just going to do these in a relatively shorter fashion. So there it is, and then I'll just work that all out in my calculator and give the two different t values. So 0.5 or t equals 1.99 or 2.0, so approximately there. So when is the ball above 2 meters above the ground? Between 0.5 and 2 seconds. And so that's how we would go about solving that. So going back to some of that quadratic equation type of activity. So creating a model. Again, we use this formula here with our initial velocity and our height that we substitute in. This again is just for projectile motion when we're shooting something up in the air given a initial velocity and a height in meters per second and then a height in meters. So how long does it take to hit the earth? We just use a quadratic formula, find out when it what time it hits 0. The maximum height is found in this case by just finding the middle of the zeros and then solving for the height at that time. And then when the ball is 2 meters above the ground again, we set the height to 0, or sorry, set the height to 2, rearranged it so that we have 0 equals the quadratic equation, which we can then plug into our quadratic formula and solve that. Anything above, between those two times, the ball will be above the ground. And why is it that case? Because the ball is going to go like this, and so it's going to be above in 0.5 and 2 seconds. Okay, I got a couple more questions here to check out. The product of two consecutive even numbers is 528. What are the numbers? This is an easy question. I mean, like 528, well, let's see, some number, it's got to be between 20 and 25, so I'm just going to play around and try and find some numbers that work. And you can trial and error this for sure. And those of you that like to do trial and error, that's great, except it's tedious, an extra amount of time, especially if I gave you a number like 5,643,923, then what would you do? Well, then I wouldn't do trial and error and I'd do the proper method. Try the proper method first. Avoid trial and error unless it's a situation where we have no method other than trial and error to solve it. So in this case, we can use quadratics to find two numbers because the product of two even numbers is, consecutive even numbers is 528. Well, one number could be x. The next consecutive number that is even, the next number is x plus 1. The next even number is x plus 2. And that equals 528. So x times x plus 2 equals 528. So if we do a little bit of expansion here, we get x squared plus 2x, 28, x squared plus 2x equals 528. Move the 528 over, x squared plus 2x minus 528 equals 0. Now I have a quadratic simple trinomial. I know they're two even numbers. I can go about solving that either by using the quadratic formula, but I know they're two even numbers. They're going to be between 20 and 25. How do I know that? Because 20 times 20 is 400 and 25 times 25 is 625. So they got to be between 20 and 25. They got to be even. The only two even numbers that will work are 22 and 24. But if I test that out, 22, negative 22 and positive 24 will give us 2 when we add them up. Negative 22 times 24 will give us negative 528. So we had x minus 22, x plus 24 equals 0. And then x minus 22 equals 0, or x plus 24 equals 0. So when we go to solve these, x equals 22 or x equals negative 24. So these are two possible numbers for x. So x is either 22 or x is negative 24. Now, these are not the two numbers because negative 24 and 22 are not consecutive numbers. So if x equals 22, then 528 divided by 22 equals positive 24. Therefore, 22 and 24 are possible numbers. If you did that, I'd give you part marks because you're not done. Because what's the other possibility for x? It's negative 24. Negative 24 is an even number. The next consecutive even number after negative 24, well, if x equals negative 24, then if we do 528 divided by negative 24, we're going to get negative 22. So the other pair of possible numbers is negative 22 and negative 24. So there's actually two sets of numbers that work, and that is why we like to use the quadratic method. If we didn't, what we would have got was 22 and 24. You would have figured that out and been, okay, it's all good. But it's not the only answer. There's two possible answers in this case. So do be cautious with that. Next method, or next question. Sorry, we have one leg of a right triangle is 4 centimeters longer than the other leg. The hypotenuse is 8 centimeters longer than the short leg. What are the three side lengths? So we had a right triangle going on here. So let's actually draw it out just to give us a little visual. The three sides, we have one leg that is 4 centimeters longer than the other, and then the hypotenuse being 8 centimeters longer than the shorter leg. So our short leg here, we can use x. This next one could be x plus 4 centimeters longer, and then our hypotenuse could be x plus 8 centimeters longer than the short leg. So now we have this sides. We can put them into an equation that we know works with right triangles, which is the Pythagorean Theorem. A squared plus b squared equals c squared, where c is the hypotenuse. So x squared plus x plus 4 squared equals x plus 8 squared. So now we have three sides in there, and if we expand these out, we get x squared plus 8x plus 16 and x squared plus 16x plus 64. And then we rearrange everything so that we can solve for x. We can combine the two x's here, x squared, 2x squared plus 8x plus 16, and then I'm going to move everything else over. Minus x squared minus 16x and minus 64 equals 0. So we got 2x squared minus x squared, that's x squared. We got 8x minus 16x, that's going to give me negative 8x. And finally 16 minus 64 is going to give me negative 48, and that equals 0. So now we have a simple trinomial. We can try and solve that for x and see what it is. So if I look at that, two numbers that multiply to negative 48 and also add to 8. So what are two numbers that multiply to negative 48, add to 8? Well, it's numbers that multiply to 48, 12 and 4. Negative 12 plus 4 is 8. Negative 12 times 4 is negative 48. So that's my pair of numbers. X minus 12, x plus 4 equals 0. And then we solve these. X minus 12 equals 0, or x plus 4 equals 0. So x is equal to 12, or x is equal to negative 4. Now, the side length of a triangle cannot be negative. We don't have negative measurements as our side lengths, so this one's not possible. And so this one here is our answer. X is 12. So if x is 12, x plus 4 equals 12 plus 4, or 16. And x plus 8 equals 12 plus 8, or 20. Therefore, 12, 16, and 20 are the sides. So there's my 3 side lengths of that triangle. So again, when we're working with the right triangle, we know that we have the Pythagorean theorem that relates all 3 sides. So I used the Pythagorean theorem to relate the 3 side values that I had. Did some algebra in there, rearranged, and solved for x. Again, in this case, in some of these problems, you got to use some common sense as to what's going on and some logical thinking as to the real world situation. You can't have a negative length, thus we can't have a negative 4 result here. In this case here, just consecutive even numbers. Why is the negative number allowed? Because there's no constraint saying that we can't have negative numbers. It's just 2 numbers. So any 2 even numbers, negatives, yes, they are even numbers as well. So in both cases, it worked. And then in the case of our ball falling to the earth again, real world constraints, we're not going to have negative times. Our time starts at 0, and thus we have our positive time value here. In the second case, both values were okay because both values were above 0.